Hello students, good morning to everyone. This is Bujji Babu, working as a chemistry lecturer in Vignan Cooperative Junior College, Vadlamudi. In morning session, today's our topic is solid state. So in previous video, I already completed the chapter of the solutions regarding second year chapter of the intermediate. So this is a new topic to you. This solid state also belongs to second year intermediate chemistry. It is a physical part of the chemistry. So in second year intermediate chemistry, there are four important chapters are there for very essential in the IP pattern, objective pattern. So among them, the first one is a solution chapter, and the second one is a solid state chapter, and third one is electrochemistry, and fourth one is chemical kinetics. These four chapters are more essential in the view of objective pattern. So in every JEE main examination, one of the question came from these chapters. In a solid state also, this is more essential for an IP pattern and objective pattern. So students, mainly in this solid state, we are mainly focusing on solids. You know that very well, matter existing in three types in the universe. So what are they? In solid form, liquid form, and gaseous form. So especially in intermediate second year level, we are focused only about the solid state. So what are solids, and how can we define if the given substance is a solid or liquid or gas? So what are the general characteristics of solids, and what are the classification of these solids, and what are the main general characteristics regarding to the solids? And next one, what are the cubic structures of the solids and the arrangement of the atoms presenting in this solid? So every day we are using so many substances as they are presenting in solid state in our daily life. So this solid state is the main essential. So why? So here many of these substances are presenting in the solid state. So solids are very hard and brittle due to their rigid structure. So the arrangement of the molecules in a solid is quite different compared with liquids and gases. So in a solid state also we are going to explain the dimensions and the arrangement of the atoms in a three-dimensional pattern, one-dimensional pattern, and two-dimensional pattern also. So the arrangement of the solids in different types of dimensions, and then we have to calculate the total number of atoms presenting in that every cubic structure. So every cubic structure consisting of 6 parameters, 3 edges and 3 angles. Based on these 6 parameters, again the solids are classified into many types. Okay, once we have to look at the contents which are present in this video are first one, introduction about solid state. Introduction about solid state. So generally, matter existing in three types: solid, liquid, and gaseous state. So compared to liquids and gaseous, solids are having different properties due to the arrangement of the particles, that means ions, atoms or molecules which are presenting in the solids. And next concept is general characteristics of solid state. What are the general characteristics of solid state? So the general characteristics means solids have definite shape and definite volume. The strong electrostatic forces are attractive forces, the binding forces which are present in the solid state. So based on the presence of these strong attractive forces, solids are very hard and brittle. And compared with the liquids and solids, these solids are having a special unique properties compared with the liquids and gases. And next one, amorphous and crystalline solids. Solids can be classified into two main categories. First one is crystalline solid and the second one is amorphous solid. So how can we define if the given solid is either in the crystal form or in the amorphous form? So due to the arrangement of the particles which are presenting in the given solid, that are said to be either crystalline or amorphous. In a crystalline, the particles, that means ions, atoms or molecules, are arranged in a regular pattern. Amorphous means in Greek language, amorphous means no form. The solid substances which are presenting in amorphous form, they do not have any definite structure. So this is about the classification of solids into crystalline solids and amorphous solids. And next one, distinction between crystalline and amorphous solids. Distinction between crystalline and amorphous solids. It gives the information about the what are the melting points of crystalline solids and amorphous solids. And next one, cleavage property of crystalline solids and amorphous solids. And next one, thermal conductivity of crystalline solids and amorphous solids. So this is gives the information regarding to the crystalline solids and amorphous solids. And finally, classification of crystalline solids. Classification of crystalline solids. So solids mainly classified into two categories, that are crystalline solids and amorphous solids. Again, crystalline solids can be classified into four types: molecular solids, ionic solids, metallic solids, and covalent or network solids. So these are the main classification of the crystalline solids. So these are the main contents which are presenting in this present video. And next one. So the general introduction regarding to the matter. So what is meant by matter? Matter existing as three forms in the universe. Matter existing as three forms in the universe. So first of all, what is meant by matter? According to the chemistry, how can we define the matter? So matter can be defined as, it have mainly containing two properties. What are they? The first one, it having some mass and occupying some space. The substance which having some mass and occupy some space, then we have to set it to be that substance is in matter. So generally, this matter can be existing in three forms, that are mainly solids, liquids and gases. Solids, liquids and gases are main three existing form of the matter in the universe. So among these three, we are going to explain about particularly solids in this chapter, that is solid state. We are surrounded by solids more often than liquids and gases. I already mentioned in our regular life we are using so many types of solid particles, solid materials in our regular life. So that's why we are surrounded by many of these solids more often than liquids and gases. So compared with the liquid and gaseous, in our surrounding we are surrounded by many of these solid substances, and we are also using many of the solid substances. For different applications, we need solids with widely different properties. So for different applications of the solids with widely different properties. So basing on the different properties of the solids compared with the liquids and gaseous, the wide range of these solids can be used in. And next one, these properties depending upon the nature of constituent particles and binding forces operating between them. So the wide properties of these solids mainly basing on the 2 points. What are they? First one, constituent particles. Constituent particles means the atoms, ions or molecules which are presenting in the given solid. Some binding forces operating between them. Some binding forces present between the atoms, ions or molecules which are presenting in the given solid. So based on these two properties, the presence of the constituent particles and the binding forces which are operating between the constituent particles, the wide range of these solids can be defined. And next one, the correlation between structure and properties. Structure and properties helps in discovering new solid materials with the desired properties, like high temperature superconductors, and next one, magnetic materials, and next one, biodegradable polymers for packing, and biocompatible solids for surgical implants. So basing on the special features of the solids, these the correlation between structure and the properties. The structure of the solids and the properties of the solids mainly helpful in a wide range of their uses for discovering new solid materials with desired properties like high temperature superconductors. These high temperature superconductors are used in wide range for industrial purpose. And next one, magnetic materials. So many of the magnetic materials are solids. And biodegradable polymers which are used for packing purpose. And next one, biocompatible solids for surgical implants. So these are all the wide range of the solids mainly based on the correlation between structure and their properties. And next one, the liquids and gases are called fluids because of their ability to flow. So this is a special feature regarding to the liquids and gases because they are also called as fluids because they are ability to flow. So it is not possible in case of solids. So only liquids and gases are ability to flow basing on the property they called as fluids. And next property is the fluidity in both of these states is due to that fact that the molecules are free to move above. So why the liquids and gases are called as fluids basing on the property the molecules which are present in them are free to move above. So basing on the free movement of the molecules, the substances like solids, substances like liquids and gases are called as fluids. And next property, the constituent particles in solids have fixed positions and can only oscillate above their mean position. This explains the rigidity in solids. Generally, solids are having rigid character. So compared with the liquids and gaseous, these solids have rigid character. So the rigid character of solids can be attributed to the solids have fixed positions and can only oscillate above their mean positions. So in the solid, the particles are fixed with their original position and they can be oscillate above their mean position. So this is the reason for the rigid character of the solids. In crystalline solids, the constituent particles arranged in regular pattern. So this is another important point regarding to the solids. They have different properties compared with the liquids and gaseous. That is known as the arrangement of the particles in regular pattern. In every solid, the particles like atoms, ions, molecules are arranged in regular pattern. So look at these two images. Some of the solids are present here. So these are all some cubic structure and triangle shape and circle shape solids. So these are all some bricks, coal and rocks. So generally bricks, coal, rocks or this type of different types of cubic structures and triangle structures, all these are presenting in solid shape. So why all these solids have definite shape and definite volume and have rigid property? All these properties of the solids are so attributed to the constituent particles arrangement which are presenting in the solids. Next one, general characteristics of solid state. So what are the general characteristics of solid state or general characteristics of solids? Solids have definite mass, volume and shape. This is very clear. Every solid has a definite mass, volume and shape. So basing on all the properties of the solids are attributed to the mainly the arrangement of the particles in them and the arrangement of the particles in a regular pattern. So this is the main point. And the constant of the particles and they oscillate their mean position. These two are main important properties. The solids have definite mass, volume and shape. Interatomic molecular ionic distance are short. In case of solids, these two are important. Interatomic or molecular or ionic distance are short. Because in the solids, the particles are very closely packed or tightly manner. That's why the interatomic distance or the molecular distance the ionic distance are very short in case of solids compared with liquids and gases. Interatomic molecular ionic forces are very strong. This is another important point regarding to the solid. Interatomic forces present between the particles, intermolecular forces present between the molecular forces, interionic forces present between the constituent particles in solids are very strong because the strong electrostatic forces are present in between them. That's why the tightly packed arrangement of the particles presenting in these solids. Their constituent particles like atoms, molecules or ions have fixed positions and only oscillate about their mean position. This point already mentioned previously. The constituent particles which are presenting in solids like atoms, molecules or ions have fixed positions and only oscillate about their mean positions because solids have a rigid property. So this is a related one. They are generally incompressible and rigid. So this is a different property of the solid compared with liquid and gas. They are generally incompressible. Generally, liquids and gases are compressible property, but in case of solids, due to the arrangement of the particles, they are very incompressible and having rigid character. So these are the unique properties regarding to the solids. And come to the next one, crystalline solids and amorphous solids. So what are crystalline solids and what are amorphous solids? A crystalline solid consisting of a large number of small crystals, each of them having a definite characteristic geometrical shape. Generally, solids can be classified into mainly two types: crystalline solids, first one, and second one, amorphous solids. So this information about the crystalline solid. So what is meant by crystalline solid? A crystalline solid consisting of a large number of small crystals in their structure, each of them having a definite characteristic geometrical shape. So this is the important point. The constituent particles which are presenting in a given crystal substance, the constituent particles have a particular geometrical shape. In a crystal, the arrangement of the constituent particles, atoms, molecules or ions is ordered. That means, order means the arrangement of the constituent particles like atoms, ions or molecules in given crystalline substance, they are orderly arrangement. There is a particular order of the arrangement of the particles in crystalline solids. It has long range order. Another property for this one, it has a long range order, which means, so what is meant by long range order in case of crystalline solids? Generally, crystalline solids have long range order. Long range order means that there is a regular pattern of arrangement of particles which repeat itself periodically over the entire crystal. So this is the meaning regarding to the long range order. So what is that? Regular pattern of arrangement of particles which repeats itself periodically over the entire crystal. So even in the given the entire crystal, the regular particles are repeated again and again. So therefore, that meaning is used to the long range order of the given crystalline solid. And next properties regarding to this one about crystalline solids. So that is crystalline solids except cubic crystals. In case of crystalline solids, except cubic crystals are anisotropic in nature. They are anisotropic in nature. So what is meant by anisotropic nature? That is some of their physical properties like electrical resistance or refractive index, IR values, refractive index show different values when measured along the different directions in the same crystal. So that gives the meaning of the anisotropic in nature. Crystalline solids are having long range order and anisotropic in nature. Anisotropic nature means if you are calculating some physical properties of that crystalline solids, that are electrical resistance and refractive indexes, refractive index over the different directions over the crystal, they show different values. They show different values. So that is a property of anisotropic nature of the crystalline solid. So look at this arrangement of the particles in crystalline solids and amorphous solid. So anisotropy in the crystals and isotropy in the amorphous solids. Anisotropic character in the crystalline solids and isotropic character in the amorphous solids. In anisotropic character in the crystals, the arrangement of the particles are have definite order. In case of amorphous, the arrangement of particles are not in a particular form because amorphous means no form. The arrangement of the particles is do not have any particular pattern. But in the view of anisotropic nature and isotropic nature, I already mentioned about this point. In case of crystalline solids, we have to calculate some physical properties like electrical resistance or refractive indexes. We have to calculate these values over the entire crystal that gives a different values. Show different values. This is in case of the crystalline solids. In case of the amorphous solids, we have to calculate the physical properties of these substances like refractive index or electrical resistance that gives the same value in all directions of the crystal. So this is the difference between the anisotropic nature and isotropic nature. Anisotropic nature in crystalline solids and isotropic nature in amorphous solids. The best example for this one is sodium chloride. Crystalline solid, the best example is sodium chloride. This is known as the rock salt structure. Sodium chloride, rock salt, general formula sodium chloride. It is the best crystalline solid, that is sodium chloride. So once you have to look at this image, in that image, the arrangement of the particles about sodium chloride. Sodium chloride general formula is NaCl. It consisting of Na plus ions and Cl minus ions. So here sodium chloride has a cubic structure. In that cubic structure, so you have to see here some of the positively charged particles and negative charged particles are present here. The positive charged particles are indicated with Na plus ions and negative charged particles are denoted with Cl minus ions. So every solid structure, that is a crystalline structure, have a cubic structure. So in the previous video we are going to learning about the cubic structures of the solids like simple cubic structure, body centered cubic structure and phase centered cubic structure, and we have to learn everything in previous sessions. So this is about the structure of the sodium chloride. It also have a cubic structure. So the arrangement of the particles is like this manner. Okay, this is about the three-dimensional structure of the sodium chloride. It is the best example for the crystalline solid. And next example for this one is quartz. So quartz is the best example for the crystalline solid. So once you look at this image, in that image also the quartz particles arranged in a regular pattern and they also have a dimensional shape. So that's why quartz is also a best example for the crystalline solid. So many of the solids are presenting in crystalline form only basing on their arrangement of the particles. The arrangement of the particles like either atoms, ions or molecules which are presenting in them are having a definite order of their arrangement. That's why they have the rigid character and incompressible property. These two are best example for the crystalline solids. What are they? Sodium chloride and quartz. And next about the amorphous solids. So what are amorphous solids? So amorphous solids means in Greek language regarding an amorphous solid in Greek, amorphous means no form. Amorphous means no form. So amorphous means no form, that's why it has no orderly arrangement of particles. No orderly arrangement of particles. So even in the crystalline solids, the arrangement of particles have definite order, but in case of amorphous, according to their meaning in Greek language, amorphous means no form. That's why they has no orderly arrangement of particles. They do not have any particular shape. The arrangement of constituent particles like atoms, ions or molecules in such a solid has only short range order. They also have only short range order. In the case of crystalline solids, they have long range order. They have long range order. In the case of this one, they have short range order. Short order means the arrangement irregular and periodically repeating pattern is observed over short distance only, over short distance only. Okay, in case of the amorphous solids, the arrangement a regular and periodically repeating pattern is observed over short distance only. That's why these amorphous solids have short range order. And next property regarding to them, such points are scattered and it is between the arrangement is disorder. So this is regarding to the amorphous solid. Such points are scattered and in between the arrangement is disorder. The arrangement of the particles, constituent particles in amorphous solids in disorder manner. Example, quartz glass. The best example for this one is quartz glass. So this is a image of the regarding to the quartz glass. Quartz glass is in amorphous form. This is a powder form. It do not have any form. So amorphous means in Greek language no form. That's why quartz glass is in amorphous form. It appears as like powder. So therefore amorphous solids they do not have any particular shape. Okay, next one, an important thing regarding this one. Distinction between crystalline and amorphous solids. So what are the main differences between the crystalline solids and amorphous solids? So once we have to look at this table regarding to the crystalline solids and amorphous solids, first one come to the first point, shape. So shape of the crystalline solids, they have definite characteristic geometrical shape. In case of amorphous solids, they are in irregular shape. They do not have any shape because of their order. Next one, melting point. So crystalline solids are melted at a sharp and have characteristic temperature because of their structure. In case of amorphous solids, gradually soften over a range of temperature because they are presenting in amorphous form. And a cleavage property. When cut with a sharp edge tool, they split into two pieces and the newly generated surfaces are plain and smooth. So because of the crystalline solids, when cut with the sharp tool, they have newly generated surface areas and plain and smooth. In case of amorphous solids, when cut with a sharp edge tool, they cut into two pieces, the irregular surfaces because they do not have any particular shape. Next one, heat of fission. In case of crystalline solids, they have a definite and a characteristic heat of fission because of their having arrangement of the particles. In case of amorphous solids, they do not have definite heat of fission. They do not have any definite heat of fission. Next property, anisotropic. Crystalline solids having in anisotropic in nature. In case of amorphous solids are in isotropic in nature. So anisotropic nature means I already mentioned. Anisotropic means we have to calculate the physical properties like refractive index or electrical resistance over the entire crystal. They give different values. In case of amorphous solids, isotropic means the physical properties of the substance have same values in over directions. And in nature, these crystalline solids are true solids and amorphous solids are pseudo solids or supercooled liquids. Generally, we are called as amorphous solids, but they are not pure form of the solid. Sometimes they are also called as a supercooled liquids. Supercooled liquids are in the arrangement of constituent particles. In case of crystalline solids, long range order. In case of amorphous solids, only short range order. This is a main distinction between the crystalline solids and amorphous solids. Next one, again crystalline solids are classified into four types. The main classification goes to crystalline solids can be classified in two types, crystalline solids and amorphous solids. Again crystalline solids are classified like this one. Crystalline solids can be classified on the basis of nature of intermolecular forces operating in them into four categories that are. Again, crystalline solids classified into four categories. That classification based on the intermolecular forces which are present in between them. First one, molecular solids. What is that? First one, molecular solids. And next one, ionic solids. Second one, ionic solids. And third one, metallic solids. And fourth one, covalent or network solids. So these four are main classification about the crystalline solids, molecular solids, ionic solids, metallic solids, covalent or network solids. So come to the first one, molecular solids. So what are molecular solids? So molecules are the constituent particles of molecular solids. In case of molecular solids, the main constituent particles are molecules. They are further divided into the following character. Again, these molecular solids again classified into three types. So what are they? First one, non-polar molecular solids. Second one, polar molecular solids. And third one, hydrogen molecular solids. Again, molecular solids classified into three types. What are they? Non-polar molecular solids, polar molecular solids, and hydrogen molecular solids. Come to the first one, non-polar molecular solids. What are non-polar molecular solids? So they can be defined like this. They comprise of either atoms, for example, argon and helium. For example, argon Ar and helium He. Argon, Ar and helium are the molecular forms by non-polar covalent bond, for example, hydrogen, chlorine and iodine. So generally in case of non-polar molecular solids, they contain a non-polar covalent bond. Best examples are argon, helium and hydrogen, chlorine and iodine. So non-polar molecular solids consisting of a non-polar covalent bond between the atoms. In these solids, the molecules are held by weak dispersion forces or London forces. Weak dispersion forces are London forces. The forces which are presenting in between the molecules in the non-polar molecular solids are weak dispersion forces or London forces. Weak dispersion forces are London forces. These solids are soft and non-conductors of electricity. These non-polar molecular solids are having soft character and non-conductors of electricity. Non-conductors of electricity. And next one, they have low melting points or usually there are low melting points and usually in liquid or gaseous state. This is important. In a liquid or gaseous state at a room temperature and pressure. These non-polar molecular solids having very low melting point and usually in liquid or gaseous at ordinary room temperature and pressure. At ordinary room temperature and pressure, these non-polar molecular solids have very low melting points and compared with liquids or gaseous state. And come to the next one, polar molecular solids. So what are polar molecular solids? In second classification, this one regarding to the molecular solids, the molecules of substance like HCl and sulfur dioxide are formed by polar covalent bond. So the name indicates that polar molecular solids having polar covalent bond. The polar covalent bond of the substances like HCl and SO2, they contain polar covalent bond in between them. The molecules in such solids are held together by relative strong dipole-dipole interactions. In case of polar molecular solids, the forces which are present between the molecules are strong dipole-dipole interactions. In case of non-polar molecular solids, the forces are presenting in like weak dispersion forces or London forces. But in case of polar molecular solids, they are presenting as a strong forces like strong dipole-dipole interactions. These solids are soft and non-conductors of electricity. These as like non-polar molecular solids, these polar molecular solids also having soft character and non-conductors of electricity. And next point, come to the melting points of these polar molecular solids. Their melting points are very high compared with the non-polar molecular solids. So the melting point of the polar molecular solids are higher compared with the non-polar molecular solids. because of the bond character, nature of the bond. In case of non-polar molecular solids, there is a non-polar covalent bond is present. In case of polar molecular solids, here a polar covalent bond is present between the molecules. So that's why the melting point of these polar molecular solids are very higher compared with the non-polar molecular solids. Most of these are gaseous or liquids under room temperature and pressure. At room temperature and pressure, these polar molecular solids are presenting in the form of the gaseous state or liquid state. And come to the next one, hydrogen bonded molecular solids. So this is another classification for molecular solids. Second one, first one is molecular solids. Hydrogen bonded molecular solids. The molecules of these such solids contain polar covalent bonds between hydrogen and fluorine, oxygen or nitrogen atoms. Hydrogen bond formation takes place always between one hydrogen atom and a highly electronegative atom like oxygen, fluorine or nitrogen. The strong hydrogen bonding binds molecules of such solids like water in a solid state, that is ice form. So the formation of the hydrogen bond like this. For example, in between the two atoms like hydrogen and another electronegative element like X. So due to the electronegative character, the pair of electrons always attracted by the highest electronegative element by X. Therefore, hydrogen possesses a partially positive charge character, and this halogen consisting of partially negative charge due to its highest electronegative character. This partially positive charge hydrogen atom attach with or react with another highly electronegativity atom like oxygen or fluorine or nitrogen. So the hydrogen bonding generally represented by with dotted lines like this, with the dotted lines like this. The hydrogen bond present between the hydrogen and oxygen, hydrogen and fluorine, and hydrogen and nitrogen. So therefore this is a very weaker bond. Hydrogen bonding. Therefore, the molecules of such solids contain polar covalent bond between hydrogen and highly electronegative atoms like fluorine, oxygen, nitrogen. And next point is they are non-conductors of electricity. These hydrogen bonded molecular solids are also non-conductors of electricity. They are volatile liquids. Another property regarding to them, they are volatile liquids or soft solids under room temperature and pressure. At room temperature and pressure, these hydrogen bonded molecular solids are volatile liquids or soft solids. They have the property due to the presence of the hydrogen bond. And come to the next classification regarding to the crystalline solid is ionic solids. Second classification is ionic solids. So what are ionic solids? Ionic solids are mainly consisting of the constituent particles are ions. Ions are constituent particles of ionic solids. Such solids are formed by three-dimensional arrangement of cations and anions bound by strong coulombic forces or electrostatic forces. So ionic solids are very strong because the strong electrostatic forces or coulombic forces present the ions which are presenting in. These solids are hard and brittle in nature. These solids are very hard and brittle in nature because of the strong electrostatic forces or coulombic forces which are bind the ions presenting in the solids. And also they have high melting and boiling points. So compared with the remaining solids, these ionic solids they have high melting points and boiling points because they have strong coulombic forces or electrostatic forces present between the ions in solids. So therefore they have high melting point and boiling point compared with the other solids. The ions are not free in the ionic solids. The ions are not free to move about. They are electrical insulators in solids. They are electrical insulators in a solid state. Generally in the solid state, these ionic solids they connect as the insulator. So basing on the conductivity, solids can be classified as conductors, semiconductors and insulators. If the electrical conductivity is more, that are said to be conductors. If there is no electrical conductivity, because they called as insulator. If it is a partial conductivity is there, they are said to be semiconductors. So because in pure state of the ionic solids, they are act as insulators, especially in solid state, because the ions which are presenting in them are not free at all. There is no movement of the free ions, that's why they can act as insulators in solid state. And next property regarding to the ionic solids are, however, in the molten state or when dissolved in water, in molten state or when dissolved in water, the ions become free to move about and they conduct some electricity. So this is the conductance of the ionic solids, because they are presenting in the solid state, they do not have any free ions, they act as insulators. So however in the molten state or the ionic solids are dissolved in the water, they possess some free movement of ions, and due to the free movement of the ions, they are able to conduct some electricity. So they can act as a conductors in liquid form or aqueous form. So look at these some structures regarding to these ionic solids. The ionic solid best example is sodium chloride, cesium chloride, barium chloride, and potassium chloride. Many of these there. So ionic solids are arranged like this manner. They have definite shape and volume. So the arrangement of the particles in ionic solids, the ions, for example in case of sodium chloride, Na plus ion and Cl minus ion. So Na plus ions and Cl minus ions are having strong electrostatic forces or Coulombic electrostatic forces present between them. That's why they have different shape and volume. They also have three-dimensional shape. So once you have to look at this image, the ions are the ions which are presenting in ionic solid, how they rotate and they, in three-dimensional manner, they have different shape and volume. The arrangement of the particles like this this is a three-dimensional view of ionic solid. And next one, you have to see another image for this ionic solid is like this manner. Here also some of the ions are represented with yellow color and red color. So the arrangement of the particles that are ions are arranged in a particular order and in three-dimensional manner. So this is the arrangement of the ions in case of ionic solids. They have fixed positions and they have strong electrostatic forces or Coulombic forces between them. That's why they have possess a different properties like high melting point or high boiling point. Okay, so these are all few examples and arrangement of ions which are presenting in the given ionic solids. Come to the metallic solids. So what are metallic solids? So metals are orderly collection of positive ions surrounded by and held together by a sea of free electrons. So in metallic solid generally consisting of a metal. So metals are always having positive charge due to the loss of electrons. These metal ions are surrounded by collection of positive ions surrounded by and held together by a sea of free electrons. Sea of free electrons. And next one, these electrons are mobile. These electrons are mobile and are evenly spread out throughout the crystal. So these electrons are having mobile character. That means they have to freely movement from one place to another side of the crystal. So they have evenly spread out throughout the crystal. That's why they have different properties. Each metal atom contributed one or more electrons towards this sea of mobile electrons. See, in metallic crystals, the metal ions surrounded by a number of free sea of electrons. So every metal atom in crystal contribute one or more free electrons, sea of mobile electrons. Therefore, These free movement of electrons, they have different properties. These free and mobile electrons are responsible for high electrical and thermal conductivity of metals. So general metals are high electrical conductivity and thermal conductivity based on the free movement of ions. So free and mobile moving of electrons in metallic structure, they have high electrical and thermal conductivity in case of metallic solids. Our next important point regarding to the metallic solids is when electrical field is applied, these electrons flow through the network or opposite ions. So the free movement of electrons which are presenting in metal, when we are applied an electrical field, these free electrons flow through the network of the positive ions. Positive ions means metal ions. Around the metal ions, this free movement of electrons are flow through the network of positive ions. Another important point regarding to them, when the heat is applied to one portion of a metal, the thermal energy is uniformly spread throughout by free electrons. For a given metallic solid, when we are giving some heat is applied to one portion of the metal, we are applying some heat. The thermal energy is uniformly spread through by the crystal by free ions. So this is the only due to the free ions. When we are giving heat to the one portion of the metal, the heat is, the thermal energy is uniformly spread throughout the portion of the metal due to the free electrons. Another important point regarding to them, metal have luster in nature. And color in certain cases, and this is due to the presence of free electrons. Due to the presence of free electrons or mobile electrons in metals, they have some luster in nature and they also have exhibit some color. So another property, metals are highly malleable and ductile nature. Metals having highly malleable and ductile nature. Ductile means they have gold metal. We have to they can be separated like pieces. And ductile malleable property. Malleable property means the metals are having the capacity. They have to stretch it to some sheets. That is known as the malleable property. And last category of this classification of crystalline solids is covalent or network solids. So what are covalent or network solids? This is the last classification. So a wide range of crystalline solids of non-metals, only for non-metals, result from the formation of covalent bonds between adjacent atoms throughout the crystal. They are also called as joint molecules. This is important for covalent or network solids. So in case of covalent or network solids, the crystalline solids of non-metals results from the formation of covalent bonds between adjacent atoms through the crystal. In the given crystal, the covalent bonds are presenting between adjacent atoms through the crystal. They are also known as joint molecules also. That means in covalent or network solids, the covalent bonds are present between the adjacent atoms throughout the crystal. And next point regarding to these covalent solids are, covalent bonds are strong and directional in nature. The covalent bonds which are present in covalent or network solids, they are very strong and directional in nature. Therefore, these atoms are held very strongly at their positions. The atoms which are bonded with covalent bond, they are very strongly at their positions. So this is about the covalent or network solids. These covalent or network solids are very hard and brittle because of the strong character of the covalent bonds which are presenting in between them. Next one, they have extremely high melting points. They have extremely high melting points. And may even decompose before the melting point. So these covalent or network solids having extremely high melting points, even though they decompose before their melting point also because of the presence of the covalent bond. And another property regarding to them is they are insulators. They are insulators and do not conduct electricity. These covalent or network solids are act as an insulator because they do not conduct electricity. There is no free movement of electrons. Okay. In case of solids, if there is a conductivity is attributed to them to only the free movement of electrons or mobile electrons, otherwise it is not possible. So diamond and silicon carbide are typical examples of solids. So here diamond and silicon carbide are best example for the such solids that are covalent or network solids. So this is a arrangement of the particles in a diamond. So in diamond, the carbon particles are arranged like this, a tetrahedral manner. So the arrangement of the particles between the so diamond and graphite are allotropes of carbon. You know that very well. So allotropic means the given substance existing in more than two or more forms. So that are allotropic forms. The main allotropic names of carbon are diamond and graphite. So in diamond, the carbon particles arranged in the particular tetrahedral manner. Each carbon atom bonded with neighboring atoms, and the bond present between the two atoms is a covalent bond. So in covalent or network solids, the covalent bond is present between them. So this diamond also cannot be act as a it act as a insulator. So here there is no free movement of electrons according to the structure. Therefore, in each carbon atom bonded with the neighboring atoms, and between the two carbon atoms a covalent bond is present between the atoms in diamond. So this is the structure regarding to the diamond. And come to the next one. Graphite is a soft and conductor of electricity. Graphite is soft and conductor of electricity. Soft and conductor of electricity. So here both the diamond and graphite are allotropes of carbon, but a diamond is a insulator, but a graphite also act as a conductor. It is not insulator. Graphite is a soft and conductor of electricity. So what is the property difference between the diamond and graphite? Both are allotropes of the carbon. They treated as allotropes of carbon, but diamond act as a insulator, but graphite act as a conductor of electricity because of their only structure. Because of their only structure. So this is a structure regarding to the graphite. So once you look at this image, in that image this is the structure of the graphite. So in a previous structure we are seeing the structure of the diamond. In a diamond, carbon atom bonded with neighboring atoms with some covalent bonds. Here also carbon atoms are arranged in a hexagonal ring. Carbon atoms are arranged in a hexagonal ring in case of graphite. But diamond act as a insulator, but a graphite act as a conductor of electricity. So what is the reason behind? What is the reason behind in case of graphite? Why graphite act as a soft and conductor of electricity? So look at this image clearly. You have to see in the structure each carbon atom bonded with three neighboring atoms. Each carbon atom bonded with three neighboring atoms. Each carbon atom, first of all, in the structure of the graphite, carbon atoms are arranged in hexagonal rings, and each carbon atom bonded with three neighboring atoms, and fourth valency electron of each electron present between the two atoms. So each carbon atom bonded with three neighboring atoms. And next one, the fourth valency electron of each atom present between the two atoms like this manner. The fourth valency electron regarding to the each atom present between the two carbon atoms like this manner. This is electron is a mobile electron. Due to the free movement of electron, mobile electron or free electron to enter crystal, to enter these rings or enter crystal of the graphite. So it acts as a conductor, and these hexagonal rings are slide 1/1. That's why this graphite also can act as a lubricant also. It also acts as a lubricant, and also it conduct electricity only due to the free movement of electrons between the two atoms in each layer. So this is the main difference between the diamond and graphite. So it is not possible in case of diamond. So in case of graphite, only the arrangement of the particles as hexagonal rings. Each carbon atom bonded with the neighboring three atoms, and fourth valency electron of each atom present between the two atoms like this. This free electron moves to entire crystal. So this is attributed to the electricity. Therefore it act as a graphite act as a conductor of only free moment of electrons which is present between the two atoms in each layer. So therefore graphite can also act as a lubricant because only these hexagonal rings are slide one over. So that's why this graphite can act as a best. Graphite can act as a soft and it act as a lubricant and it also conductor of electricity. Okay, finally I concluded. So what we learned in this video are, so in this video we are especially designed about the solid state. In a solid state, what are the characteristics of the solids and what are the general characteristics of the solids, and mainly classification of the solids like crystalline solids and amorphous solids. So the distinction between the crystalline solids and amorphous solids, again crystalline solids classified into four types: molecular solids, ionic solids, metallic solids and covalent solids. Again molecular solids are classified into four types. What are they? Non-polar, polar molecular solids and hydrogen bonded molecular solids. So this is about the introduction part of the solid state and the classification of the solid state, and regarding to the classification of the main solids and the classification of the crystalline solids, and each information regarding to the about basic terms regarding to the solid state. Okay, thank you students, thank you very much.